Hello everyone, welcome to the channel. So in today's video we will be going to solve a Leetcode problem of the day, that is maximum width ramp. Problem number 962. So let us understand what the problem says. So the problem says, first of all, it defines what is a ramp in an array. It is a ramp in an array is a pair from index I to j. Okay. Ramp is anything in the array that could be a subarray. Uh, okay. From I index to jth index. And next second thing, that nums of I is less than equal to nums of j. Okay, that is element present at some index I that appears before j should be less than or equal to nums of j. Okay, and the width of such a ramp is minus I. So j minus I is nothing but formula to calculate width from index I to j. If we want to, if I want to suppose calculate width from index and this to this, that is from index 1 to 3, I can simply do 3 minus 1, that is 2. The width from index 1 to 3 is 2. Okay, so let us try to understand a little more. Okay, so let us take this example and try to understand the problem in depth. So we have to return a maximum width ramp. Ramp is nothing but we can say it as subarray, and with the conditions like subarray with conditions like I should be less than j, strictly less than j, and secondly element present at index I less than equal to element present at index j, that is nums of I should be less than equal to j. So this is the definition of ramp they have given. Okay, we have to find this, and let us try to solve the problem using a brute force approach. So the brute force approach, the problem is nothing but calculating all the subarrays from I to j. Okay, and in that subarrays, checking the conditions I less than j, and particularly I should be less than j. We don't need to check this, but the condition, that is nums of I less than nums of less than equal to nums of j. Okay, building all the subarrays and checking the condition that fulfills uh, the ramp, you know, the condition they've given uh, for ramp. And so we have to return maximum width wala ramp na. So we can make a variable called maximum width with 0, and in any subarray where we find a ramp with maximum width, we will update this variable. Okay, simply we update this variable. Let us try to run this approach, that is making subarrays and checking the ramp condition. So to make subarrays, take we have to take 2 pointers, that is I, and that is at index 0, and j, that is at index 1. So we are going to build all the subarray, that is first from 0 to 1, then 0 to 2, then 0 to 3, 0 to 4, 0 to 5, and after from 0, after first jth loop is done, we will move our ith pointer to index 1 here, and here we will build all the subarrays from 1 to 5, from 2 to 5, from 3 to 5 index, from 4 to 5, and from 5 to 5, and so on up to last. Okay, So firstly our I pointer is at 0 and j is at 1. So check the condition that 6 is less than equal to 0. No, so we will move our j pointer. Okay, so simply move j pointer. Okay, that is increase the length of the subarray from 0 to 2. Here again same condition, that is the nums of I is less than nums of 0 not, that is 6 less than equal to 8. So yes, the condition is fulfilled. So we will update our making a variable called max width, and now we have find a ramp from index I equal to 0 to j equal to 2. So now we can calculate the width of the ramp, that is j minus I, that is 2 minus 0, that is 2. So we have found a ramp with maximum width. So we can update this variable to 2. Okay, now we can move our j pointer, because this could be our possible answer, but we we are not sure that this is our maximum width ramp or not. So we will move our j pointer to further check that maximum width ramp exists further or not. So we move our j pointer here. Again check the 6 is less than equal to 2 or not. No. So move our j pointer again. So here 6 is less than equal to 1 or not. No. So again we will move our j pointer here. 6 is less than equal to 5 or not. No. So in the first jth loop we have find a maximum width ramp of 2, that is from index 0 to 2, that is this one. Okay, this one. So now we have done with first j loop. Now we will update our I pointer from a 0th index to first index. Again we have to do the same thing. Now our I pointer is here and j pointer is at I plus 1, of course, because I should be less than equal to less than I should be less than j. J pointer is here. Again in this subarray, again we have to check the same thing, that is 0 less than equal to j or not. Yes, so it could be our possible subarray. Okay, this could be our answer. So at this point we can calculate width. How? That is j minus I, first index, second index, j minus I should be 1. Okay, so now here we will update this or not, because the possible answer at this point we can find is 1, but our maximum width is 2, so we will not update this because we have already maximum, that is 2. So this could not be our maximum width wala ramp. So now we will again move the jth pointer. Again we will check, here is j pointer. Again we will check that in this subarray nums of I is less than equal to nums of j or not. 0 is less than equal to 2. So this could be our possible answer. Calculate width, that is j minus I index, that is 3 minus 1, that is 2. So we may or may not update our max width variable. Okay, because 2 is already present and the new answer also is 2. So we may or may not update the variable. Next again we can move our jth pointer. Okay, here. Now again check 0 less than equal to 1 or not. Yes, so the possible answer now is j minus I, that is 4 minus 1, that is 3. So new answer is 3 coming, and that is greater than max width variable, so we will update this to 3. Okay, now again check, move this j pointer here and calculate the width, that is 5 minus 1, 5 j minus I, that is 5 minus 1, that is 4. 4 is greater than 3, so update it. So now at this point we don't have to check move our I pointer again, because if we, because here we have find the max width uh, after the j reach end of the array, we have found the maximum width ramp. Okay, now if we try to move the ith pointer, this simply will, we are shrinking the answer, because see, so see if our answer is coming from this point up to the end. Okay, and now if we check this part, this will possible give less width while answer. Okay, so we no sense to check further, and we will return the maximum width ramp, that is 4 here, that is from index 0 to 5 we are getting our maximum width. So this solution probably gives us n square time complexity, because we are first loop is running up to n, and the second also to n minus 1. So this will probably give us time complexity of n square, which is obviously not good. Let us try to solve it another way, that is our two pointer approach. Or I can say it's sliding window also. The example was 608215. Okay, so two pointer approach always gives the solution in time complexity of we go of n. So this is better than n squared. So how will we going to solve this using two pointer? So we will be taking two pointers, that is I and j here. Okay. So this problem is will be going to be solved in sliding window approach, that is sliding window watch approach. Say if you are familiar with the sliding window approach, what we will do, we grow and shrink our array in some cases, shrink where the given condition does not fulfill, we will shrink the array, that is how we will see it, how we will do, and grow the array if our condition is getting fulfilled. So doing something like that. So here see, um, two pointers are there, I and j. Similarly we have to check here, that is nums of I less than equal to nums of j or not. 6 is not less than equal to 0. So here our condition is not getting fulfilled, this condition is not getting fulfilled. So what sliding window says, that now we can shrink our, we can't find answer here in this part, so we can shrink our subarray, that is shrinking means moving the I pointer. Okay, shrinking means this is the array, we shrink it to some smaller subarray, moving this pointer. Okay, moving this pointer, we can, if the I was present at here, we can moving I pointer forward, we can shrink the subarray. So here we will be going to do the same thing, that is shrinking the subarray. Now our I pointer is here, and j is j we can move here. Okay, again we have to check here that in nums of I less than equal to nums of j or not, that is 0 less than equal to 0 or not. Yes, it is. So we can here grow our subarray. That is grow. How can we can grow? We can simply increase the jth pointer. Okay, here. So before going, we can build the answer also. So here we are finding the possible answer. So here previously we are finding the possible answer. So we can update the maximum width, that is index 2 minus 1, that is 1. Answer, possible answer could be 1. And now we are at index 1, 2, 3. From 1 to 3, I is at 1th index and j is at 3rd index. Again we check this condition, that is 0 less than equal to 2 or not. Yes. So before going our subarray, we will check that maximum width is that the new answer is greater than maximum width or not. Yes. So we will update it to j minus I, that is 3 minus 1, that is 2. Okay. Now we can grow that because the condition is getting fulfilled, so we can grow the subarray. Here is j pointer. So j minus 0 is less than equal to 1. So 0 is less than equal to 1. So j we will update the width, that is 4 minus 1, that is 3. Again condition gets fulfilled, so we can move the jth pointer to last index. Again here check 0 is less than equal to 5 or not. Yes. So calculate width, that is j minus I, that is 4. Okay. So this is our answer we have got, that is 4, using a 2-pointer approach in big of and time complexity. But this solution doesn't work in the case if uh, let us see in what case this solution fails. I pointer is here, j pointer is here. So nums of I is not less than nums of j. So we will simply move the I pointer here and j here. Okay. And previously and similarly we will do the same thing up to the end of the array, and the answer would be here would be this much, that is these are indexes. Answer in this case would be 5 minus 1, that is 4. But this is not the right answer. Why? Because the right answer in this case is that is from index 0 to index 5. You can see that at index 0 we have 6 and index 5 we have 6, that is less than equal to 6. Okay. And in this case our answer could be 5 minus 0, that is 5. But using previous approach we are getting answer 4. This is not the right answer, and this could be right if we do not have equal condition. We have strictly less than. Okay. So what we can do that so here what intuition we can apply that after we have shrink the array from this to this. but our answer lies here. That is max width ramp answer lies here, but we have already shrink the array. So here we will, what do we need to do? You know, we will do some pre-processing kind of thing. पहले से ही process कर लेना. Process needs मतलब think like. So what the mistake we are doing, that we are shrinking the array. Okay, but the real answer lies before shrinking the array. Okay, so we will do some pre-processing here before shrinking this array to this array. We will do some pre-processing here. Okay, so what kind of pre-processing we will do? So just think that what we have to do here at this point. I is here, j is here, checking the condition nums of I less than equal to j, and it is not right, and moving the pointer I plus plus. Before moving this pointer, we have to do some pre-processing. That is, if at this point we will check that in this array, that in this part of the array, that is in this part of the array, if there exists some larger number, how we will be going to check the larger number, we will see that. So the pre-processing is check the larger number at index at index at any index of nums array. This is our nums array na. So before moving I pointer, we will check the condition that if there exists some larger number in the remaining array or not. Okay, so we can make a max right, we can say, array that is storing the max element from particular range. So we will start it from and storing the maximum right element. So here we will put 6, and in this array what is the maximum large element, that is 6, and again in this range we will check the maximum, that is 6. Here from here to here we will check the maximum large, that is 8, and from here to here we will check maximum large, that is 8, and similarly here we will check maximum large, that here that is 8. So this 8 indicates what? This 8 indicates the maximum element that is present up to this index to up to last, and this 8 indicates the elements that are present from this index to, that is this is suppose the pointer here is r, and r is at 1, and I is also at 1. So at 1 we will check the at 1 we will check that in further array maximum element exists or not. So that thing we will check at nums of r. Okay, maximum width array में r index पे any element indicates the largest element from this index up to the last, and similarly this indicates the largest element from index this index, that is 2 index to up to last. and this 6 indicates the element present at this index, that is fourth index up to last, and this 6 from index 5 to 6, and this at index 6. Okay, so now we have the maximum right subarray where each element indicates the where each element indicates the largest element present from that index up to last, from that index in the nums array, from that index in the nums array up to last. Okay, I will repeat again. The element at an index in maximum right subarray indicates the largest element in the nums subarray from that index to up to last. Now we have our maximum right subarray. So now we will try to solve this, try on this. So here we will take I pointer in this nums array, and in this we will take L pointer, going from left to right, and here we will take pointer name R in the maximum right array. So suppose our L pointer is at this 0th index, and here we have to check the condition that if element present at nums of L is less than equal to maximum right array का rth index वाला element. So if this condition is true, that is 6 is less than equal to 8. Okay, what it means that there exists some answer in the further array. Okay, so we will there is answer variable. So 6 is less than 8 equal to 8, which indicates that there exists answer in the further array. Okay, so we will not move our this pointer, which we are doing in that example, where we haven't done any pre-processing or have not this maximum right array that is telling the at particular index telling us that there exists some larger element in further array or not. Now we have this maximum right array that is telling us that there exists some larger element in the remaining array. Okay, which could make possibly the answer. So now this could be our possible answer. So we can start a right index from I have to start, I think I should start our my right pointer from this index, but no worries. Now move our pointer here. Previously it was here. Now again we have to check if 6 less than equal to 8. So this, yes, so this could be our possible answer. Okay, R minus L, that is 1 minus 0. Okay, so 1 minus 0 is 1. So 1 with array can give this answer, that is from 6 to 0. Now we will move our right pointer again. 6 less than equal to 8. Yes, so there exists a possible answer in this range also, from 6 to 8. So we will calculate the answer, that is R minus L, 2 minus 0, that is 2. Update the answer. Now move the R pointer here. 6 less than equal to 6. Yes, so possible answer could exist in this range also. Okay, this range. Okay, so again possible answer could be R minus L, that is 3 minus 0, that is 3. So update answer, that is 3. Now again move the R pointer. So the 6 less than equal to 6, less than equal to 6. Yes, so there possibly could exist the answer between this range to this from 6 to 1, that is from 0th index to 4th index. So 0th index to 4th index. So possibly exist answer here also 4 minus 0, that is 4. Again move the R pointer here. So 6 less than equal to 6. Okay. Yes, so possibly exist answer from here to here. Okay. So we will update our answer variable, that is 5 minus 0, that is 5, 5 minus 0, that is 5. So maximum width we got is 5. Okay, this is our answer. So in the case if the condition was not true, suppose here exists 5. Okay, so 6 is not less than 5. In that case we will move our L pointer. Okay, in that case we will move our left pointer, because this 5 tells that uh, no larger element exists in the remaining array, so you don't need to check it. Okay, suppose the array is like 5 1. Suppose maximum right array is like 1 2 3 4 5. So in first comparison 6 less than equal to 5 is not true, so of course it will not be true for further remaining array also. Okay, we can't have our maximum right in a further also, so we will not check the remaining array. Okay, so let us try to code this approach. So I will be coding that sliding window code that we have recently done. Let us try to. So we will storing the length in an variable, and first of all we have to make a maximum right array, and of size of same as a nums array. Okay, so in Java we have to do arrays dot fill with default value, that is 0. Okay, now let us build the maximum right array. Okay, so we have to build it from right to left. Okay, for int I equals to n minus 1, I up to 0th index, that is I greater than equal to 0, I plus plus, and here we will be keeping track of the previous maximum element, that is 0. So update the previous max if we so here our maximum right array looks something like this. Okay, so updating this maximum right variable in this case starting from n minus 1 na. So previous max was 0, and in this array we have 5, so check what is greater from 0 and 5, so we will update that variable with 5. Okay, now our previous maximum will be 5. Okay, now again check between 5 and 1. Okay, which is the greater 5. 5 and 1, which is the greater 5, so we will update it as 5, which indicate that from this index to this index we have the from this index to this index. From this to this, we have the greatest element, that is 5. Now again, update previous, that is 5 again, and now again check 5 with 2. Okay, because we know that in this array we have largest 5, so check it with 2. So again from 2 to 2 and 5 we have largest element, that is 5. Update it. Now move the pointer here. So from this index to this index, we know the largest element is 5. So comparing 8 and 5, we get 8. Again check 8 with the, now our previous maximum becomes 8. Okay, now again check 8 with 0. From 8 and 0 we have the greatest element, that is 8. Now update here 8. And from 8 and 6 we have greater element, that is 8. Update it. So in this way we are making a maximum right sub array. So there is a function called math.max which return the maximum of 2 elements. We have to check it with the current nums of 5 with the previous maximum. Okay, that is keeping track of the previous maximum elements. Okay, now we have maximum right array that looks something like this. Okay, so further we have to do nothing but just apply that pre-processing approach. So in this R pointer, that we have to loop up to n. So here we have to check if nums of I am creating a L pointer that is pointing in this nums array. Okay, and this R pointer is pointing in maximum right sub array. Okay, so if nums at L is less than equal to max right R index, then there exists a possible answer. Okay, in the case 6 6, if the 6 is less than, if there is 8 and 6 less than equals to 8, so there exists a possible answer. So a similar thing we are doing here. So possible answer exists, then we have to make some result variable that is storing result. Update it. How we can update it? Maximum of result, and how we get that possible answer, possible width, using R minus L. Okay, so if this condition is not true, we have to shrink the window. Okay, how we just update our L pointer. Okay, the pointer that is pointing to nums array. Okay, so this much, and we have to return our result here. Let us start to at I with the previous max. What is the problem? So these are some small mistakes that I made.